if in your actually there is something called Maven Archetype itself creates a test directory. Any unit tests and other things you can write it here. Yes, yes, that's it. While people are compiling it, I'm going to cover some more theory so that we are more comfortable with the. Still compiling, maybe we'll just do a little bit more. If you have any doubts, we can always come back to it. So in the okay, in the previous exercise we just printed the data, right? We got the data, but we did not do anything with it except for printing it. Now we are going to pass it on to a handler and install a flow, because whatever rules that we got, we want to translate it into a corresponding flow and install it on the switch. So we will pass it on to a handler and install a flow here. So in the handler is another class. I'm going to use the method install flow there. So if you open the for this exercise, we can directly go to that sample app 3 directory, and we can compile it from there, because the only reason is in the interest of time, because we have more files to be copied into your directory structures, and we have another pom.xml changes, features.xml changes. Sorry, everything is there in the slides what you need to do, and it is also there in the readme. So for the interest of time, instead of copying it into your directory, we can go to the under tutorial sample app 3, we can go there and we will execute it. Yes, yes. So here what happens is, like, there is another class that we've written which is called the sample app data store handler. Data store handler meaning that what is the information that we got from the MDSAL data store, we pass it to this class, and this is going to do the business logic there. So the handler object. So we got a data broker, and then this is another MDSAL API manager. Okay, what is this MDSAL API manager? Like I said, we got the information, we get all this access control list, we get the rules, and we get the source and destination IP address and all that. But that we have to translate it into a rule. And this rule is nothing but an OpenFlow specification based rule. So we have to construct OpenFlow constructs, like a flow object, and then that has another nested matches, actions, instructions. So that it's a you have to have a more in-depth knowledge to be able to construct that object. So to make it very easier, and also because this is again reusable across all projects, there is another project called Genius, and Genius has something called MDSAL API. It's just a wrapper or utility that is built on top of this OpenFlow basic OpenFlow constructs, which any application can directly use it, and using that you can easily construct. It eases the construction of a flow, group, table, whatever that the OpenFlow constructs need. So, and so this MDSAL API manager resides in another feature, that is the Genius feature. So now your sample app needs to specify dependencies on that feature. So only then you will be able to access this class and be able to call methods on this class. So that this is another feature. So this is Genius is one feature, and the other feature that you will need is the OpenFlow plugin. Okay, so we will need a Genius feature here, and so what we will do is we will call, see, once that's during the construction itself, I need this Genius feature. We will see how this we can get it before we go to the how we do it. It is okay. Genius feature has I mean, it's a project. It's a feature which has several components to it. One is the utility which is built on top of specifically for OpenFlow. So if you want another utility functions that you can do it, but this MDSAL utility is specifically built to construct your flow, group and thing, because most of the applications, that is what the use cases are. Among several things, one is a utility amongst, not MDSAL I would say, utility amongst OpenFlow, how to quickly construct OpenFlow Java construct like this flow, groups and other things. Excuse me. Hello. So if you see the blueprint of this exercise, from the initial one, the blueprint we've added more stuff here. If you see the data broker, which we already had before, and then this is the MDSAL utils that we are talking about. This is coming from OpenDaylight Genius. MDSAL util. So this is the API manager that we want. So this is the original, the provider that we have not changed. It is the same provider. There's only one provider here. And then this is the sample app listener, which we had already had it in the previous exercise. The extra thing that we've added is the API handler, because this is another new Java class that we are writing, for which we want the data broker, and then we have the MDSAL utils, which we just defined above. MDSAL utils is what we just defined here. The utils ID that you have to define, and this is what. So when this object getting instantiated, these two references will be injected. Okay, but then this reference is not a part of this feature, right? So at runtime, this feature will not be installed, right? So we have to define. You have to say somewhere that when I'm installing this, you need to install that feature, because this won't be installed, so it will not be instantiated, it will not be available in the memory. So somewhere you have to say that. Only then you will be able to inject this and be able to get the reference here. So that we will say using your features.xml. So if you see here, we'll say other features, to integrate other features. For instance, services from other features, OpenFlow Plugin Genius, you can be utilized here. To bring in the dependency, you have to do a certain things like the implementation form.xml. You will need a dependency onto the API, because those are the interfaces to those corresponding classes that you want to make you available there, use there. And in the features form.xml, you will have to include which artifact ID, which feature that it is, and also the information about how to get that feature. And then you will inject them in blueprint. The blueprint injection we just saw. We will see the form.xml and the features.xml, where you will say specify. In features.xml you will say this is the artifact ID of the feature that I'm interested in and how to fetch that. here in the form.xml of the impl, you will specify what you depend, because when you compile the impl, this mdsal API, because this provides the API to the mdsal utility thing that we want to use. So you have to define this in your form file. Only then at compilation you need this dependency here. So that is what you define here, and these are the other things that you define for the OpenFlow plugin, the flow service, flow base. So like I said, this utility from Genius is only a wrapper to build your flow objects, and you will then have to push it down to the switch. So how do we push down to the switch? If you go back to our ODL OpenDaylight architecture, you have service abstraction layer, you have applications on top of your MDSAL, which is the service abstraction layer, and then you have the plugins below, right? So the plugin is for instance, since we are going to talk OpenFlow, there is an OpenFlow plugin. So that has to be instructed to say push the switch, push this flow to the switch, correct? So what we have done so far is, from your JSON, you've inputted a rule that went to MDSAL, and then you've registered a listener saying that when something changes, let me know. So that listener has gotten that information of the source IP, source destination IP address, and whether to permit or deny, right? So then we are going to use this Genius to easily, quickly form rules, and now the next step is you have to instruct the OpenFlow plugin to push that rule to the switch, right? How do we say? Again, what we will do is, once we construct a flow using this Genius MDSAL API, we will write it back to MDSAL. See, so what happens is, the usual communication between modules happen through MDSAL, right? Like Manohar was mentioning, this flow has to be in config, in the config database. Only then, when the switch gets, say for instance, switch gets disconnected and the switch connects back, the rule has to be pushed again, right? Because every time the operator cannot be pushing the rule. So somewhere it has to be persisted and it has to be pushed. So that persistence happens in the config data store of inventory. So what happens is, when you get the information, you use this form of flow and write it onto that config inventory. So what plugin does is, it again registers a listener on that config inventory. So when you write onto the config inventory a flow, plugin has a listener, and so that will get the flow object, and then it will serialize it and then send it down the wire. So if you look at it, MDSAL API, all the typical way of application is, one application will write onto it, the other application will listen on that, do some business logic, and you might write again, and then something else might. So that's how the general, a lot of things happens this way. Like for instance, in the morning there was a network session where from OpenStack you can create network and other things. So there is a neutron component that from OpenStack, when a network gets created, that gets written onto MDSAL. There is a YANG for that. Again, everything is modeled in YANG, right? So then there are components in ODL that listens on that and does something else down the wire. So everything kind of happens through MDSAL. So some correct. No, that's what, it depends on the use case. See, not everything has to come from your user. Like for instance here, the first user input was your ACL. You said whether permit or deny and all that. That was an external user input. Then you wrote that sample app listener, you listen to it, and then you construct it. Now again you will write. So the person who is writing onto MDSAL need not necessarily be always driven from some external event, right? So what happens is, you've already gotten an external event from the user. There's only thing is, I want to configure an ACL. That's all it is. So then you have written this, an OpenFlow plugin is a very generic one which will say any flow you write I will push it onto the switch. So where do you write the flow? That applications will write onto the inventory config. Right? So the first time that something was written was through YAN, but the next time that we are going to write, as is from the sample app data store handler, we are going to write onto the empty cell. I hope everybody got the, so this is the basic crux of how things are done here. So for the OpenFlow plugin, you need all these other dependencies here. So this is the impl pom, and then if you see the other one that we are mentioning is the features. Features has something called it has features.xml. So for instance, this is where you say this is a genius feature. I want a ODL genius feature, and this is the OpenFlow plugin feature. So you will specify what are the, I am dependent on these features. So when I am loading this is how to fetch this feature is what you will mention it here. So there is two features that we want to mention. One is the OpenFlow southbound plugin, and this is the genius. So these are the two features that we are dependent on. This you will specify in the features.xml. Yes, sample app -3. So that is what here we talked about the features, how you can integrate with other features, and this is what we said by having microservices, that you can put smaller features and you can use other features to achieve a larger use case here. So this just talks about what Genius is, and the other things you can go in depth into the Genius wiki page also, and to find what this provides. And then I think we are not getting too much into this, because first we'll do the sample app 3 before we talk about entity ownership and cluster singleton, like I was mentioning other person. Across cluster, if you want to share the load sharing, you can register a cluster data tree change listener, where the listeners get fired on all the nodes, and then you can choose where you want to execute that particular business logic. So these are the next step that you would want to get into it. So then we'll do the exercise 3. I'll give the thing to Gaurav, where we will go through the exercise 3. Maybe people can start compiling sample app 3. Yeah. So what you could do is you could go into the sample app directory, and there you can do all the Maven clean install minus the 3 options. There you can do. So like I said, with the interest of time, we are not going to copy all these things to your directory where you started it. It's the same thing. So you can, the only change here will be, like, the impl has a few extra files. 1 minute, I probably want to show the, 1 minute. Impl. Maybe you can start the compilation. We'll just go through a few. No, that's what I mentioned. Yeah. here if you see, there will be a lot more data, the coding here, which will get the destination, the rule name, and you will have to build a corresponding OpenFlow Java construct. So a lot more coding there. You will have to build what is called, if you have to build what is called a flow entity. This is the OpenFlow construct that we were talking about. So for the flow entity, you have to specify the cookie, then you have to say what are the matches, so and then list of actions, so and then set a priority for the rules, so instructions, and then the rule has what is called a hard timer, hard timeout, idle timeout. So all these are, if you go through OpenFlow specification, you can see all this for a flow. So you need to set all this, and then you will have to write it onto the MD cell. So to enable you to quickly do this is why we are using that MD cell API manager from Genius, which is nothing but a utility wrapper around this. So if you see, this is what we do. We build this, we set the source IP address. Sorry, this is a sample app data handler. Data store handler, yeah. Yeah. Yeah, he will. Okay, so maybe you can start compilation. You want to start the compilation there? Before we start, please log out of the previous instance, running instance of the Karaf, and yeah. Okay, so you want to. You also want to store where it's written and all that, or is it? No, not demo. Where the code where it is written and all that. Okay, I will.
Yeah, we'll quickly have a look at the test topology we have, and then while you're compiling with the sample app 3, we'll just take a look at the test topology we have to run through the final round of the exercise.
So from here, it's the final demo of our
Yeah,
application.
this is the end-to-end demo where you'll see the actual use case of ACL as in access control list, right? The accept and permit and deny. That's the last part of the demo. So topology typically, yes, we have the controller based on stable boron code. The current master code of the OpenDaylight is what they call Carbon, but we have taken the code from the stable boron branch, and the mininet is having OVS 241 version of the Open vSwitch, and the Postman as a REST client. We'll be shooting the request to the Postman client.
Or instead of Postman, we can use that API browser.
API browser, which you've already been trying out since morning. Yeah.
Posting the request.
Correct. Correct. Yeah, so this is a very simplistic, look at how the test topology will be. Have the Postman client where you send the RESTCON request. ODL running stable boron will consume that. And so the sample app 2 per se, we have the data tree chain notification, cluster data tree chain notification. That will get the notification and write it back to the config data store. Then on the FRM module inside OpenFlow plugin, we'll program that on the southbound. Right, so that will actually send the flows on the switch. So now we'll actually play around on the OVS 241 also to look at the flow entries what are getting programmed on the switch. So we'll have basic two hosts, and host 1 trying to ping host 2 will be allowed in one case and denied in the other case. So that will be the very simplistic use case here. Okay, I think with that we'll go ahead with the demo.
Okay.
Yeah. Or you want people to try, come back after the coffee break. 4-5 is the coffee break.
Yeah. 4-5
do
is
the
a
final
break.
demo.
Okay, then we'll do a demo after.
Maybe you should start the compilation.
Have the coffee break, come back for the last demo.
Compilation done?
It's like 4-5.
Yes. So 4.5 to 4.25 we have